How are you, my friends? This video is presenting the 7 old exams questions related to dividing polynomials from lecture 36 of the Algebra Course Lectures. Let's start directly. We have polynomial function of degree 3, 3x cubed minus 2x squared minus 150. Let's divide by x squared minus 4. And we need to find the quotient and the remainder. You can also write the answer in this form. So let's directly go. So this is the function here, and the divisor is x squared minus 4. As I mentioned in lecture 36, I take the highest, the term here with the highest power, 3x cubed, divide by x squared. You know that, just it will be 3x. Then multiply again, so it will be 3x cubed minus 12x. Now you subtract, in the long division we subtract. So we cancel this. This becomes minus and plus 12. See, plus 12x. And there's a squared. Remember, you cannot add. So I said here, combine only like terms. So I put the minus 2x squared. And minus with the minus becomes plus 12x minus the 150. Again, I repeat the whole process. Divide this by x squared. So it's minus 2. Then multiply back. Minus 2x squared plus 8. Then I subtract. I put the minus before the whole expression here. So this will be cancelled. And this one will be minus 8. You see, minus 8, minus 8. And minus 150, minus 158. And 12x will come down. I stop dividing because the highest power here is 1. And the highest power here is 2, so I stop dividing. See, up here, it's the quotient, 3x minus 2. And this one, all is the remainder, 12x minus 158. You can write the answer like this or like that. Another one, really nice. We have degree 5 divided by x squared minus 3x plus 1. And I give you part of the answer here, 2x cubed. Then I hide A, B, C, and D. So for sure you have to use long division, and then all this will be the quotient, all this will be the remainder, then you multiply A times B times C times D, and the answer is a nice number. Now when you divide, maybe I can leave the division for you. I will try it. Try the first few terms. 2x power 5 divided by x squared. Remember here. It will be 2x cubed. Then I multiply by all this. So it becomes 2x power 5 minus, see, 6x power 4 plus 2x cubed. Then I subtract. So this will be cancelled. This will be plus 6x4. So there is a minus 2. And minus here, cube, I cannot add with the square because combine only like terms. So I leave the cube here with the minus. I leave the squared with 22x squared minus 10. Then I repeat the process the same way I did the first one. If you understand it, you can do it. Now, this is the question. And this is the answer. Why the answer? Because we have the quotient there, 2x cubed minus 2x squared minus 8x. And the remainder you should get 8x minus 10. Now you compare, you get 2 is there given. See, 2 in the question is there. This is not A. This is A. So A minus 2, B minus 8, C is 8, and D is minus 10. When you multiply everything together, you get minus 1280. Now, question 3, we need the value of the m if the remainder is 72 when dividing this function by x minus 4. I think here there's a little trick. 2 tricks actually. One trick is there is missing here x power 4 when you do synthetic, and also in the x you have to take a common factor here to find the coefficient of the x. So leave x power 5, rearrange it here, minus 13x cubed. See, I have to take x out. See, minus 47 plus m all in the x. See this one here, minus 47 plus m, that's the coefficient of the x. And the other numbers, all of it without x is the constant, 8 minus 5m. See, divide by x minus 4, so on the chair I put here 4. 1 comes down, multiply by 4, add, then 16, add 3, multiply by 4, 12, add, multiply by 4, 48. 48 minus 47 becomes 1, 1 plus m. Now multiply by 4, 4 plus 4m. When you add, you get 12 minus m. I said in the question, it's given here, you see, the remainder is 72. So I take 12 minus m is equal to 72. So m will be minus 60. Factor the polynomial functions completely. I put here one simple function with the squared. X squared minus 7x plus 6. I kept here the same numbers here, plus 6, minus 7. Instead of the squared, I put cube. The squared, we know how to do it. So easy. Quadratic. See, this is the answer I'll show it to you. Quadratic function, easy to factor. The sum is minus 7, the product is 6. So easy to factor, x minus 1, x minus 6, easy. Now the second one, we have a cube. We cannot factor this easily, but I gave you a condition, f of 1 is equal to 0. Now here given f of 1 is equal to 0, then 1 is a 0. So on the c value, we put 1, and we know x minus 1 is a factor. So one of the factors would be x minus 1, given there. We need the other two factors. Since 1 is a 0, that means if we use synthetic division and divide, the remainder should be 0. So I put here 1. Remember, there's a squared here missing. So I put 0 for the squared, minus 7 and 6. I divide by 1, because f of 1 is 0. That means 1 is a 0. So I use synthetic division until I get remainder 0, and I know it is 0. So why I divided? To get the quotient. Remember this answer. I use synthetic division to get the quotient, x squared plus x minus 6. Then use factoring, x minus 2, x plus 3. Now, suppose you cannot factor, I mentioned earlier, you can use quadratic formula. So now the factoring of x cubed minus 7x plus 6 will be x minus 1, x minus 2, x plus 3. Try to multiply these 3 to check. Now here we need to find a polynomial function of degree 3 that has zeros 3, 2 plus square root of 5, 2 minus square root of 5. We did one similar in the examples of lecture 36. But now we will do this nice question. We have 3 zeros, and we know always if c is a 0, x minus c is a factor. Then let f of x be the function x minus c1, x minus c2, x minus c3. So I just take the zeros directly and put it there. X minus 3, that's easy. X minus the second 0, x minus the third 0. Always we have x minus c. Now here I have to be smart. I can multiply term by term, guys. If you want, you can multiply here term by term, but it will be a little difficult with some mistakes. So I can make it easy. I can rearrange it as x minus 2. See here, I changed both signs. X minus 2 in small bracket minus square root of 5. Same thing here, x minus 2 in the bracket plus, because I have two minuses, square root of 5. Then I can use here the difference between two squares. So x minus 2 is a, minus and plus, square root of 5 is the b. Now if I multiply here, this is the formula again, x minus 2 squared minus 5, because square root of 5 squared. So now we have no radicals. Easily we can continue. Expand this by the formula. X minus 2 squared will be x squared minus 4x plus 4. And there is minus 5, which will be minus 1. So x minus 3, x squared minus 4x minus 1. Let's multiply now term by term. X with the squared, x with the x with the number, etc. 3 with the x squared plus 12 plus 3. When you add everything, this is the function. X cubed minus 7x squared plus 11x plus 3. Now let's look here at question number 6. We have a polynomial function of degree 1000. We need to divide this polynomial function by x plus I, and we need the remainder. So to find the remainder, either we can use long division or synthetic division or the remainder theorem. So the easiest here is R equals P of C. R is the remainder, P is the function. Here we have the function n, and then C is the value which we divide by. C is minus I in this case. So n of minus 1 will be 6. Just replace minus I in every x. You see, every x there, every x, every x, every x. And then you have to be careful. Now we have minus I to the power 1000. Minus is a number, I is a number. So minus 1 to the power 1000, I to the power 1000. And minus I to the power 1000 is plus 1 because this is an even number. Now this you divide by 4, the remainder will be 0. 563 also, you have to divide by 4, the remainder will be 3. But remember, this is 563 is an odd number, so there is a minus 1 there. See? Here, the minus 1. And then 7 times minus 1 also in the cube, I cubed plus I squared. So let's see, this one, 6, I to the power 1000 minus 17. There is a minus 1 here because this one is odd. I to the power 563 plus 7. And there is a minus 1 because minus 1 cubed. And then I cubed. Again, we replace it by minus I. And there is a minus 1. So altogether it becomes 7 minus 1 times minus I will be plus 7i. Just be careful. I squared there. Minus 1 squared is plus 1. I squared here is minus 1. So it will be minus 1. And then this is normal. 12 times minus I. So when you add everything together, the remainder will be 31 minus 22i. Question number 7, find the product of the values of k if we divide this polynomial function by x minus k. See, this is the divisor here, x minus k. So on the chair, I put k, and the remainder is 2. So I put here the synthetic division. 1 is the coefficient, and then the squared minus 3, and then minus 4, and then 14. Then on the chair here, I put k, c is equal to k. So 1 comes down, multiplied by k, so it will be k minus 3. Then multiplied by k again, k squared minus 3k. When you add with minus 4, it will be this expression, multiplied by k again, and then add 14. Now given the remainder is 2, so I take all this is equal to 2. Bring 2 on the other side, because we have to make 0 on the right side always when we need to factor and find the solution. So you can use grouping here, easy. So you have 3 k's. K will be 3, or k will be 2, or k will be minus 2. When you multiply all of them, 3, 2, minus 2, the answer will be minus 12 is the product. Now for sure, what you can do, if you like, you can replace, see, every x here by k. You can do that. You can replace every x by k, and then all this remainder is equal to 2. Be careful here. And then you get the same solution. Now, these are the answers of the 7 questions. For other examples, please, if you want to see more examples, you can see the video or lecture 36 of the algebra course. It's called Dividing Polynomials. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you very much. Bye.